So how's everyone doing today? Yeah, fine. You have excitement?
Yes, I went to see the
Are you ready to go like on a field trip, okay, to go and take some sites? Did you get authorization for your parents for the field trip? Yeah, you signed the form and everything?
No, I need to get my parents to sign it.
Oh, that could be. Yeah, in my case, I would have to request, for my kids, would be. But anyway, that's a different story. All right, so the plan for today, I mean, we don't have much time to spend here. It's going to be like a 10, 15 minute maximum. We're going to refresh some concept from yesterday, and then we'll go all the way down to the pier over there. We're going to take all the technology that we have, which is, I mean, these fantastic sticks, okay, so don't worry. And hopefully, I mean, we'll be there. We take some sites with the sextant, we take the time, okay? And we'll note, I mean, the times and the measurements, okay, the sites, okay? That's what we're gonna do today. And tomorrow we come back to the class and then we do the math, okay? And see what happens, okay? Right? No guarantees, all right? Okay, are you ready? Well, let's review quickly some of the concepts that we saw yesterday, right? So remember that we are going to use this fantastic instrument that is called the sextant, which is this one, okay? So we went through that already. Remember that we said that this, I mean, might be a complex instrument, but the only thing that this does is to measure the angle between the horizon, which is the sea line, and the sun in this case. But it could be the sun, the moon, the stars, or whatever it is, okay? So we measure like this, we move it like this, and we're gonna practice now, don't worry. Remember that the light reflects here, go through here, and that's what we see, okay? That we're gonna use it now, so don't worry for this. That's what we're gonna use. Remember that the light of the sun will reflect on the first mirror, which, okay? Then will reflect on the second mirror, and then you will see from here. We add some filter here so we don't damage our eyes. And then we'll try to see something like this, okay? We try to move the sun, which you see like this, right over the line of the ocean, right? Or the horizon line, which is for us is the ocean, okay? So what I'm trying to do. So again, first, I mean, I'm gonna send the sextant so the sun is around here, okay? You do the fine adjustment, okay? So in order not to wait to save some time, remember that we need to move the sextant, okay, like this way, a little bit, okay? Not that much, but a little bit, okay? So the sun will move this, and we make sure that we position on the, let's say, vertical position, so where the distance is minimum, right? So that, because if we measure from here, it's gonna be an error. Okay, so we need to make sure that we're moving the sextant like this, okay, we put it in the middle, and then with the fine adjustment, which is this one, okay, this one over here, with fine adjustment, we'll put it like this position, right? We put it right on the line of the ocean, okay? And someone has to be next and say, when you have it there, you say, okay, say whatever you want, and someone is next to you, we say time, or you say time, and whoever's next to you will write down the time. The time will be hours, minutes, and seconds, okay? Which, whatever watch you have, okay? So, all right? So you have a watch like this, you can do it with this, okay? So that's the only thing we need to do. I'll be around and show you, okay? But that's the only thing that we need to do. Then, so yesterday, I mean, remember that we discussed how to read the sextant, okay? We'll do it quickly. These are the degrees, and these are minutes and the decimals, okay? So these are the minutes, degrees, I'm sorry, 20, 21, 22, okay? Are we okay? And then the minutes will be 20, 21, 22, and we need to see which one touches this, which is 4 in this case, right? Is 0, 2, 4, 6, 8, 0, right? So it will be 22 degrees, 22 minutes, 0.4, okay? Why? Because this line over here is the one that is lined up with the sign, okay? You see this one are not lined up, okay? So you need to look for the one is lined up, okay? That's the only secret. Go ahead.
So what happens if you line up with the very last one? So you said 0, 2, 4, 6,
Well,
8,
right.
0?
Right, if we line to the line one, the first one is gonna line up two. It's gonna be 2 lineups, which is the exact degree is gonna be, let's say that this one is over here, 22. So you have this one lined up that, and the last one here, because it's gonna be 22.0, okay? All right, okay, all right. And so the maximum precision is gonna be always in multiples of 2, right? So it's gonna be 22.2, 0.4, 0.6, 0.8, and then 23, okay? So that's the maximum accuracy that we can get with this, all right?
So, question.
Oh.
So that's degrees, minutes, and now you're saying decimal some number.
Right.
Or is that seconds? 'Cause that's not
No, it's not second. We are using second. We are using just degrees from here, minutes, and decimal of minutes.
Got it.
22.2, 23.3, 34.4, whatever. Okay. Seconds, forget it. We don't use seconds, okay? So it just, the maximum is going to be degrees, minutes, and decimal of minutes, Okay, and the decimal is going to be either 0, for example, 22 right, 22 is sharp, or 22.2 for 4 to 6 or whatever it is. Okay, that's the maximum with this sextants. Okay, the other sextant that you can do by 0.1, but this one is 0.2, but that's what we need anyway. Don't worry for that. All right, is that clear? Any questions? Another quick example. Okay, this example, again, we measure the degrees, 50, 55, 6, 7, it's going to be between 57 and 58. Okay, you see that? Okay, and then we come here, and in this case, it's going to be pretty much what you were saying, right? The first one is lined up on 36, 37, 38, 39. This one is lined up, this one is lined up, right? So it's going to be exactly 57 with 39. 39.0 will be, right? Okay, why? Because
yesterday we said 57 point.
yeah, depending on how you measure, because I mean, just,
8.8.
yeah, I mean, if you think that this one,
It's right there. It's
yeah, if you think that this one is aligned, it's going to be 37.8. Okay, all right. So anyway, for the accuracy that we need, I mean, 37.8 and 39 is not going to make a big difference. Okay, don't worry too much about it. Okay, all right. That's what we want to do. What else? The sextant side, where we talked about this already. Remember that what we're trying to do is, I mean, the sun is following the ecliptic, okay? And what we're trying to do is try to see when the sun is right in the middle, right? So we said that when the sun is in the middle, that will be the time that it crossed the local meridian, okay? And that's what we want to measure. We want to measure the time and also the altitude, which is going to be difficult, right? Because when the sun gets here, you will see the altitude won't change too much. Okay? It's going to be pretty much stable. That's why it's very difficult to determine the exact point that it crosses the meridian, and that's why we want to use the help of this, okay, to try to see if we can determine that time, okay? All right? So let me show, before we continue, let me show you something else. Are we clear so far? Okay. So this is what we're going to use, right? We're going to do a stick like this, okay? And this we are going to put it on the ground, and this with either with the compass like this, or with the phone, okay? With the application with the phone, we line up this north-south, okay? Which will be the direction of the meridian, right? And we put it here on the ground. If you look for the top, it's going to be something like this, right? So the sun is up here, right? At the beginning, before we go, the sun is going to be on this side, right? Because it's going from east to west, right? So the shadow or the shade is going to be this way, okay? And as the sun moves this way, I mean, the shadow will go this way, right? Do we agree on that? And we get to a point that the shadow will be exactly on this, which is the north-south direction, which is the meridian, okay? That's one important thing. The other important thing that you notice, maybe you might notice too much because we are close to the noon time, but at first, the shadow will be like this, and will be like this length, right? As the shadow moves, because the sun goes higher, the shadow will get smaller, okay? And we get the smaller point here, and then we get bigger again, or larger again, all right? Now that we are too close to noontime, so you might not notice the difference, but you do it like 11 a.m. and 2 p.m., you will see that the shadow is here, then we shrink like this, and then we'll extend again, all right? So which will be the point that we get there, the minimum distance, okay? The minimum length of the shadow that we want. It will match the north-south, and it's supposed to be, at the same time, it's going to be the minimum direction, okay? Are we okay with that? Are we clear with that? It's easier, right? So no issue, no start. Okay. The other important thing is, I mean, the other question is, what happens if we don't have a sextant, right? So how we measure the altitude? Okay, no problem. That's what we have this for as well. So we can align, we can align this, and what happens is when the sun is here, we are going to measure the length of this stick, which is going to be this one, okay? And then the only thing you need to measure is the length of the shadow over here, right? Just with this. I mean, what I'm seeing measured is this one, right? With the tape, okay? So regular tape. And you can measure it in inches, feet, meters, whatever unit you want to use. And then the only thing you need to do is to draw on a piece of paper on a particular scale the length of this, the length of the shadow, okay? When it crosses, the line, and then just get a protractor, simple protractor at home, and you calculate, see this angle. This angle is the same angle that we're going to measure with the sextant, okay? So that's the other way of doing that if you don't have a sextant. You can do this at home, okay? Just a matter of taking this length, again, in whatever unit you want to take it, take the length of the shadow, do like a little diagram like this. They have to do in scale, right? So this and this has to be in scales, okay? If this is 12 inches and this is 10 inches, we need to do whatever scale. Okay, that's the only secret. And then you measure with the protractor the angle, the same angle. Okay? Same thing that we're going to do with the sextant. Okay, so that's the other way of doing that. I mean, if you don't have a sextant. All right, is that clear? So, yeah. All right. Ask any question you want. Okay, so I went a little fast because yeah, it's trigonometry. I mean, if we're not complicate it a little more, I mean, you take the length of this, you take the length of this, you divide it, take the cotangent, the inverse of the tangent, which is basic trigonometry, and you get the angle as well. But we are not getting that complicated. So I get a piece of paper, draw this, and a scale, measure the angle, and that's it. That's what we need to do. Okay? All right? Perfect. Well, that's good, you know. I am too good to explain that nobody else anything. Okay, well, that's good. Okay, but this is pretty much what we say, right? Okay, before we do that, let me show you just one more thing. Okay, before we do that, no rush. Let me show you let me show you here. Oh, just one more thing. How we want to measure the time? Okay, well, the best way of measuring the time or synchronizing your clocks or your watches is by going to time.gov, which is the official, you know, government timekeeper, let's say. Okay, okay, and this here you have two measurements. You have the local time, which is the computer time. Okay, but also somewhere here you have either the UTC time, which is the one that we will use later, and this is, you know, the local time, which is the computer time. Okay, right? So these are the official time and the most precise time that we can get from the atomic clocks and everything somewhere in Colorado. I don't know what they are. Okay, so that's the most precise way of doing that. If you don't have access to internet and you have a GPS, the GPS also will give you the time. Okay, so there's a function you can see the time on GPS, and then take the time for the GPS. Okay, so that will be the other option. Okay, but I mean, if you don't have it, I mean, you can coordinate with us. Okay, this is free from the government. Okay, just one of the only few things that we get free from the government. Okay, but we pay taxes. Okay, so at least we get something. Okay, okay, something we get. Okay, anyway, this is that clear? Okay, that's fine. It's time.gov, easy. Huh? Time.gov, very easy. All right, and the last thing that I want to show you is on Stellarium. I know that you are familiar with, I know you are familiar with Stellarium, okay, so nothing new for you. So what we're trying to do with this is the sun in the morning, right? So let me show you what, if we advance the time, what the sun is gonna take the ecliptic, and it's gonna cross, as you can see, here it's gonna cross this meridian, the south-north meridian. We've already passed it, we'll go back, okay? So we'll cross the meridian around that time. So it's going to be 1740, which is 1240 now. So it's going to be in 20 minutes or so. Okay, so we don't have much time. Okay, so this we are simulating. Okay, so we are simulating on the ecliptic. We are going to measure this this altitude, which is 10, 40, 30, 10, 20, 40, 50, around 60 degrees. Okay, that should be pretty much at the height that we measure, and this should be pretty much the time. Okay. We don't need this, okay? I'm showing you this, I mean, just to let you know what we're doing, right? But if you don't have this, we can do it anyway, right? Just a graphic representation of what you're doing, okay? And the last thing is what happens if, as I said, it's very difficult to measure the exact time, okay? So what you guys do in practice, and we are gonna do today because we don't have the time, but what you guys, the way that we should do it to get more precision, you measure the altitude, for example, at this time, this UTC, right? But doesn't matter. You measure the time when the sun crosses 10, 20, 30, 40 degrees. And then you write down the time, okay? Then you wait after noon passage until it gets to 40 degrees of altitude, and you get the time as well, okay? So let me move this, okay? Oh, I'm sorry. So you get the time when the sun was, let's say, 40 degrees, and then you get the time when the sun is 40 degrees again, but on the other side, okay? You get one time and the other time. To get the exact time of passing the meridian, it's just the average of two, okay? You get the first time, the second time, you add it together, divide it by 2, and then it will give you the exact time that will cross the year, okay? That's the way you do in practice, okay? Today we don't have time to do that, so we are gonna try to take the time over here, okay? But in practice, you take one before, one after, pretty much the same altitude, that's important, and then you do the average of the time, okay? And then you get the time of passage, all right? Okay? Any questions? Are we okay?
How long would it take on a day like today to go from 40 to
Well, we can do it. Here is a 44. 20, 14 is like 6 hours. Okay, so it's like 3 hours before, 3 hours after. It doesn't have to be 3 hours, it could be 2 hours before, but some significant time that you can see that is the same. Okay, doesn't have to be 3 hours exactly. Okay, you can take time with one. All right, is that clear? Are we okay? All right, let's go. So let's walk to the pier area there. We're gonna set these. Now we take sides. Okay, well the sextant we're gonna put some filters here. Okay, so we're gonna put like a tray with 3 filters here or 2 here. Okay, let me take a quick look, see what happens. And the other thing we need to do is remember that we try to align. Let me see if it works. If I can. Hold on. And there we go. Okay. There we go. All right. Let me see without the filters. It looks better. So let me use this. I mean, this that sextant is pretty much the same model. So maybe 2. All right. Okay, perfect. All right. So what we're gonna do is, can you see it from there? Okay. Okay. So take this. So let me pass it around. So now the only thing you have to do, we're going to use the 2 sextants. We have a third there, so everyone can see. The only thing that we need to do is look through this, and remember that the sun has to touch this mirror. Okay. So if you did this way, it's not going to happen. That way, that's not going to happen. So put it more or less, and you will see the sun, which is like a little circle that's going to be above the horizon. And then you move this one way or the other until the sun touches the horizon, and then this is going to be the angle. Okay.
There's a solar filter or something on there to prevent.
Yeah, this is 2 solar filters. This is 1 solar filter, and this is another solar filter for the horizon. Okay. So if we take this out, I mean our eyes are going to get damaged. Okay. I mean, again, this doesn't have any magnification as a telescope. Okay. So even if we don't put a filter, like this, but I mean, your eyes will still alive. Okay. So it is not a telescope that you like this and then your eyes are gone. Okay. Forever. Okay. All right. Is that clear? Okay, well, let's start passing around, and you want it first? I'm sorry. So take it with this hand, okay? That's the only thing we need. 1 hand here, 1 hand here, okay? That's the only thing. And just put it over here so you can see the horizon, okay? And just do the sides, and then we'll pass it around. I want to calibrate this sextant as well, so everyone can see. Yeah, so, yeah, this is like a little more difficult. I mean, with practice you do it, okay? But I mean, those ones, I mean, for learning are better. But this is more precise than the other one. Okay?
Okay.
All fine? So anyone? You see already?
And what make did
Sorry?
you say this was? What make?
The make is called Tamaya. It's a Japanese brand. It was made in 1967, this one.
1967. Okay, cool.
So it's almost as old as I am, you know? So I'm 65, imagine. Yeah? All right, are we okay?
Yeah.
Do you like that? Okay, how are we doing here? How are we doing? All right, everyone look? Yeah, everyone measure. Oh, mister.
Hey, how are you, sir? I'm sorry, I had
That's
some
fine.
fires to put out.
Not a problem.
Do it again.
Yeah, do it again? Yeah, sure. Let me just make sure that it's correct. There's around there.
Buttons? You sell those buttons? Probably not.
Oh, I heard.
Right. So right hand here.
Yes.
Wow.
Well, these are Eldorado Star Party and Texas Star Party.
So right hand here, left hand here. Okay. Don't touch any of the mirror. Okay. And you will see it. I mean, make sure that this is aligned with the sun, and you will see it. Okay. If not, like move it a little left or right till you see the sun.
Oh, there it is. Okay.
Yeah, I mean, don't have to be too far, but whatever is comfortable for you. And with this part, okay? This part over here. Okay, just move it left and right until you see that the sun goes up and down and touches the horizon. That's the right side. All right, are we okay? Any question here? No, we're okay?
Much higher. And we're going to have a Messier.
All right, any question here? Are we okay? All right, it's getting hot here.
So are these? Is this technology still used today, or is it?
Oh yeah, it is. Yeah, as a backup, right? So they don't use it, but I mean, when the GPS
Now that
fails,
you have GPS and everything.
yeah, but the GPS can fail, you know. So
Exactly, so
yeah,
it's a backup.
That's a backup.
So
huh?
I'd expect most captains probably have this.
No, for sure they have, and this. I mean, you want to pass the captain license, you need to know how to use the sextant. Are we okay with that? Any question that we have? No. Anyone was able to use the sextant and take some sites at least? Okay. Anyone understood how we use the sextant pretty much? Okay, it's not that complicated. And remember, at the end of the day, the sextant is no more than a protractor. Okay, the only thing that we did was to measure the size, the angle, I'm sorry, between the horizon and the sun. Okay, that's all we did. Okay, so tomorrow we go back to the classroom at 11, and we're going to do two things. We're going to calculate latitude by using the formula of the altitude and the sun declination. We're going to use a simple formula to calculate the latitude, and then we use the time that we measure when the sun crosses the meridian to calculate the longitude. Okay, that's what we're going to do tomorrow. Okay, it's going to be simple. It's not going to be super exact because, I mean, the time is very difficult to determine the exact time. And remember that for every 4 seconds that we are off the time is going to be 1 mile difference. Okay, so you know, so if we miss it by like 40 seconds, it's going to be 10 miles. Okay, so don't worry for that. I mean, expect that. But that's the best that we can get with the system. There are better systems that we don't have time to develop or to use it, but this is the basic system. Whatever we did today here, you can do it at home, okay? So you need to have a sextant, right? Remember that if you want to do it at home and you don't have a sextant, the only thing that you need to do, can you hold this for a second? If you don't have a sextant, the only thing that you need to do is you take a stick like this and you measure this height, okay? Inches or whatever you want to do. Okay, and then measure this length, okay, the shadow length, okay, this one. That's the only two measures that we need to say, okay. You need to do it when they cross the sun or when we cross the meridian, right? So take this,
Just keep measuring it.
right, so that's the only two measures. Then, I mean, you draw like a diagram, as we said before, in a scale, and then what you're gonna calculate this is pretty much, sorry for crossing across the camera, okay, but you're gonna do this angle, okay, that's the angle you're gonna measure, okay, and this angle over here is the same angle that we measure with the sextant, okay, so you can practice at home, okay, so you need a sextant, try this at home, try to align this again true north, and have some fun, okay, and you will get the results.
Height on the,
The height is, it doesn't matter, this one is, I don't know, I mean, it is, but you know, whatever it is, it's like a 33 inches or so, but it doesn't matter, okay, so the height doesn't matter. What's gonna matter is the proportion between this height and the shadow, okay, that's what it matters, okay, this is whatever you can get, okay, shorter or longer is the same, okay, don't worry for that, that's matter. What matter is the angle, okay.
No.
No, don't worry, you know, this is the same length, but it could be anything, okay, and depending, just to finish, depending that, I mean, in summer, hey, listen to me for a second, hey, remember that in summertime, the sun is going to be higher, right? The ecliptic is going to be higher, so the shadow is shorter, okay? In winter, I mean, and the norther you go, okay, if you do it from New York, at this time, the shadow will be probably this length, okay? Because the sun here was like 50 degrees, more or less, that's what we measure. If you do the same measure today in New York, it's going to be probably, instead of 50, it's going to be 35 degrees, all right? The norther you go, the lower is going to be the sun, and the south that you go to the equator, the higher is going to be the sun, okay? So that's the only secret, okay? So tomorrow, okay, we'll do the math, simple math today, and we'll see how we get, okay? But that's all the technique, okay? So don't worry about that, take the idea, take picture if you want, okay? There's no copyright, anything like that, okay, no worry. Okay. Okay, and see you guys tomorrow at 11 at the classroom, okay? All right? Thank you for coming.